Hello Year 12s. Today we are looking at proofs for chain rule, product rule and quotient rule. All three of these proofs will require your previous knowledge on differentiation from first principles. So I'm going to do a quick recap of that from last year. So we're going to start with a basic rule for differentiation from first principle. So let's imagine we've got a curve and we are trying to find the gradient function. Okay, so what we do is we need 2 points on that curve in order to find the gradient function. So we pick one function, and that is the coordinate x, and the y coordinate is the function, so f of x. And the differentiation from first principles relies on the fact that we pick another coordinate on the same function, which is h, distance away. So I've just labelled the distance, the gap between the two variables, h. So now we have to write down the coordinates for the second point that I've picked on there, and I label that as, because it's h distance away from x, the x coordinate is x plus h, and the y coordinate would be whatever the function is, but instead of having x, it will be x plus h. So now what we can do is we can try and find the gradient function of this curve. Now, when we write down, we start with dy by dx equals limit as h tends towards 0. What that means is, because we are trying to find the generic function, the generic gradient function on this graph, we are saying that we keep reducing this gap between the two coordinates, so it keeps going towards 0, which means the gap keeps becoming smaller and smaller, which means the gradient function becomes very exact. Okay, because if the gap is bigger, rather than it being a tangent, which is the gradient function, it ends up being a chord. And I'm sure you looked at this in a lot more depth last year, so that's just why there's a limit as h tends towards 0. And to find dy by dx, which is the gradient function, in its definition we look at the difference in the y coordinates and divide by the difference in the x coordinates. Now, looking at these two coordinates that we've got here, the difference in the y coordinates is f of x plus h, take away f of x, and it's all over the difference in the x coordinates, which is x plus h minus x. We can now look at what can be simplified, and you'll see these two can be crossed out, which means the general format of proof from first principles is f of x plus h minus f of x over h, which can be found in your formula booklets. Okay, and this can then be put into practice in order to see whether you are able to now practice, whether you're not able to prove from first principles. A quick example on that: prove by using first principles that dy by dx is equal to 3x squared of the function y equals x cubed. In order to prove that, we're going to be using the same thing. Now, if we have a look at the generic graph that we've got here, I'll just draw a similar one to that. Now, I'm not saying this is to scale, it's just the generic shape of y equals x cubed, and I'm going to pick one coordinate, which the coordinate is x, and the y coordinate would be x cubed, because the function is x cubed. And I pick another coordinate, which is gap h away, which means the gap between these two is h, which makes the coordinate x plus h, and the y coordinate would be the x coordinate all cubed. And now we need to find dy by dx. Well, we know what it is, but we need to prove that it is 3x squared. So we start by saying dy by dx is equal to limit as h tends towards 0, because we're saying as the gap keeps reducing, it's the difference in the y coordinates over the difference in the x coordinates. We expand the top by using binomial. We get x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed all over, and these cancelled out again, so it's just h. We simplify again. Looking at the top, these two can also cancel out. And now we are left with 3x squared h plus 3x h squared plus h cubed over h. dy by dx is equal to, again, limit is as h tends towards 0. We divide each expression by h because each of the terms in the numerator have a h present, which means it's a common term, so it can be factorized out and it will cancel out with the h in the denominator. So we're left with 3x squared plus 3xh plus h squared. So each of the powers of h are reduced by 1 in the numerator. Now at this point is the crucial bit about this limit. Because we're saying the gap between the two coordinates as is a limit and it's going towards 0, because we're saying the gap is going to get closer and closer to 0, which is why we say the limit as h tends towards 0, you sort of write a statement. You say, as h tends towards 0, eventually what we're trying to do is we're trying to get the gap between the two coordinates to actually equal 0, because that means the gradient function at that point will be a pure tangent and will be exact. Now if that happens, it means we can now substitute the values of h as 0 into our expression. And once we do that, you'll be able to see the gradient function is purely just 3x squared. And since it's a proof question, make sure you just write down a quick conclusion. Therefore, if y equals x cubed, dy by dx equals 3x squared. Proven from first principles. In the next video, I'll be going through the chain rule with you, but I wanted to make sure everyone had a basic understanding of the proof from first principles. Okay?